Match each inequality to the graph of its solution set. Number 1 says x is greater than -4. So that is an open circle, which means we either use C or E. If it is greater than -4, it should be pointing to the right. So this one should say C. For problems 1 through 3, find a value of x that makes the statement true. Refer to the diagram of the square and the rectangle. The perimeter of the two shapes are equal. So if the perimeter of both shapes are equal, the square's perimeter is 4 plus 4 plus 4 plus 4, and then the perimeter of the rectangle is 2 plus x plus 2 plus x. So then if we combine our like terms, that would be 16 equals 2x plus 4. We would subtract 4 from both sides. That gives us 12 equals 2x. And divide by 2, and we get x is 6. For number 2, the perimeter of the rectangle is larger than the perimeter of the square. So the rectangle has that 4 plus 2x, and it is larger than, so greater than, the perimeter of the square, which was 16. Subtract 4 from both sides. That gives us 2x is greater than 12. Divide by 2. And that leaves us with x is greater than 6. We don't have to flip the symbol because we didn't multiply or divide by a negative. Number 3, the perimeter of the rectangle is not larger. So it could be smaller or equal than the perimeter of the square. Same thing, subtract 4. Divide by 2. So x has to be less than or equal to 6. It looks like we jumped ahead here. It says write an inequality to represent the perimeter of the rectangle described in problem 2. The inequality we used was 2x plus 4 is greater than 16. Then problem 5 says solve the inequality from problem 4 and graph the solution set. When we solved it, we got x was greater than 6. So to graph that solution set, we would want the numbers on the number line. We want an open circle on 6, and we want to point to the numbers greater. For problems 6 through 8, solve the inequality and graph the solution set. The only time our symbol is going to change is if we multiply or divide by a negative. So far we are subtracting, so that's a safe keeping your symbol preserved. 19 minus 12 is 7. Now I'm going to divide by -2. We just said if you multiply or divide by a negative, you have to reverse the symbol. So instead of a greater than or equal to, it now needs to say less than or equal to. That leaves us with x. 7 divided by -2 is -3.5. Looks like I need to scoot this over. To be able to fit all of my numbers on there. It is a closed circle on -3.5. And it says x is less than, so we're pointing to the left. Number 7, we're going to start by adding 7 to both sides. 1/3 x is still on the left. I haven't multiplied or divided by a negative, so I keep my symbol the same way. -8 plus 7 is -1. Now I'm going to divide by 1/3. Remember, dividing by a fraction is the same as multiplying by the reciprocal. So the same as multiplying by 3. So these undo each other and we're left with x. I have not multiplied or divided by a negative number. I multiplied by a positive 3. -1 times positive 3 is -3. So I will put an open circle on -3 since there's no underline there. X is greater than -3, so it's going to point to the numbers bigger than -3. This one's working with some decimals here. Move the numbers to the same side. I have -1.1 plus 3.5 would give me 2.4. So far I've added. That's not an operation that changes the symbol. Then I'm going to divide both sides by positive 0.4. Dividing by a positive does not change the symbol either. 2.4 divided by 0.4 would be 6. Fill in our number line. We need a closed circle on 6 because it has the equal to sign. And it says 6 is bigger than x. If 6 is greater than or equal to x, then that means the x needs to point to the left. Those values are smaller if 6 is the bigger version. Write an inequality that represents the perimeter of the rectangle described in problem 3. Problem 3 was the one that said it was not larger than the square. So we had 2x plus 4 is not larger. So that means smaller or equal to 16, but not larger. Then we solve this inequality and graph the solution set. We subtracted 4 from both sides. That gave us 2x was less than or equal to 12. Then we divided by 2, and we got x was less than or equal to 6. So on our number line, it should be a filled in circle on 6. And x is less than or equal to 6. So we're pointing to the numbers that are less than 6. A teacher gives students 16 problems that must be completed by the end of their 50-minute class period. On average, how much time can they spend on each problem? Write and solve an inequality to model the situation. So they have 16 problems, and 16 times the amount of time that it will take for each problem is going to give them the total amount of time. And the total amount of time must be within their 50-minute class. So it can be that it takes up exactly 50 minutes or that it takes up less than 50 minutes. To solve, we'll divide by 16. Since we divided by a positive number, we don't have to reverse the symbol. And 50 divided by 16 is 3.125. In B, we're going to graph the answer to the inequality. We will want an closed circle, and it says x is less than, so we're pointing to the left. Determine the range of the average number of minutes spent on each problem. Consider the restrictions to the solution set based on the context. Explain your thinking. What this means is determine the smallest amount of time it could take you to finish each problem, and then the largest amount that it would take you to finish each problem. And think about, could you have negative values as your answer? Could you have decimals? Could you have whole numbers? So the range would be 3.125 or less. So a little bit above 0, because it wouldn't take you 0 minutes to finish a problem. It would take you at least a few seconds to do it. So a little bit above 0 to 3.125. And then some restrictions. We wouldn't want negative minutes. And we also don't want it to take you 0 minutes to complete the problem, because you'll at least have to read through it and attempt it. But we could have decimal amounts of minutes, as long as they're between 0 and 3.125. How do we write the inequality if the teacher wants to use the last 10 minutes of class time to answer questions? Well, instead of it taking 50 minutes, we would need 10 minutes for completing the answering questions portion of our lesson. So we'd still have 16 problems, but we now want it to be less than or equal to not 50, but 50 without that 10. So we could think of it as 16x is less than or equal to 40 minutes now. Now solve this one and graph the solution and determine whether there are restrictions that must be applied. So less than or equal to is a filled in, pointing to the left. Determine whether the restrictions must be applied to the set. Again, no zero or negative amounts of time can be used for solving problems. Sarah wants to make bracelets for 6 of her friends. She has a total of 5 meters of elastic cord to use, but she must save 3.2 meters of that cord for another project. If Sarah uses the same length of cord for each bracelet, what are the possible lengths she can make? So she has 6 friends, so 6 bracelets, and she has a total of 5 meters, but she has to save 3.2, so she can't use that 3.2. She wants to make all 6 of the bracelets the same length, so 6 times x is going to be the length of each one multiplied by how many bracelets she's trying to make. She can use the 5 meters as long as she saves the 3.2, or she can use less than that. So now we are going to solve it. 5 minus 3.2 is our first step. That leaves us with 1.8 meters of elastic cord to work with. Then we will divide both sides by 6. And so far we haven't multiplied or divided by a negative, so we leave our symbol facing that way. And 1.8 divided by 6 is 0.3. Now we want to graph that inequality. We want a filled in circle on 0.3, and we want to point to the numbers that are less than. Determine the range of the length of the elastic cord. It can be from 0, but could it really be 0 meters? Because then it wouldn't make a bracelet at all. But we wouldn't want a negative distance for our cord. So the range is 0.3 or smaller, but the restrictions are it has to be no negative numbers, and also we can't use 0. Because then it wouldn't make a bracelet. So really we're looking at a chunk of data from here to here. The cost of renting a moving truck is $45 plus 75 cents per mile driven. Sean has $300. What are the possible number of miles he can afford to drive the moving truck? So he's going to pay $45 for renting it plus 75 cents per mile. That word per usually clues us in that we need a variable there. And he has $300. So he can use or equal 300, but he can't go over 300. So we don't want the greater than. We would want the less than symbol. Now we need to solve it. So we're going to subtract 45 from both sides. So far we haven't multiplied or divided by a negative, so the symbol continues facing the same direction. 300 minus 45 is 255. Then we are going to divide by 0.75. Again, dividing by a positive number leaves the symbol facing the same way. And that gives us x is less than or equal to 340. We need a closed dot on 340 because it has that equal to, and we want to point to values that are less than. Determine the range of miles Sean can drive. Consider restrictions on the solution set based on the context. The range here, he could drive 0 miles, and he could drive up to 340 miles. The restrictions, could he have a decimal amount of miles? Yeah, you can drive for half of a mile or a third of a mile. Could he have negative miles? No. Because even if you drive backwards, you're still going miles. It still counts as miles. It doesn't count as negative. Please make sure your workbook is filled in for lesson 21.